Okay, this is section 6.2. We are dividing polynomials. We are going to be taking a polynomial and dividing it by a monomial today. Thank you. So let's start with this example. Okay, what is a polynomial again? Multiple terms. And then a monomial is just one term. So we have a polynomial here, and we're divided by a monomial. We are simply going to break this up into three separate problems. We are really, when we say dividing by 5ab, we're really dividing each of these terms by 5ab, aren't we? So we're going to break this into three separate problems. And I want you to write it out for this first example. 5a squared b, we're dividing it by the denominator of 5ab. The second term is minus 15ab cubed divided by 5ab. And the third term is 10a cubed b to the fourth, and we're dividing that by 5ab. So we've got really three separate problems to simplify. I think we can simplify each of these. And we're going to have three different terms in our answers. So in this first term, obviously 5 divided by 5 is going to be 1. A squared divided by a is a. So we have a. And b divided by b is going to cancel, isn't it? So really all I have left there in that first term is a. For the second term, negative 15 divided by 5 is negative 3. And a divided by a is going to cancel. And b cubed divided by b is b squared. If at any time an entire term cancels out with its denominator, like the numerator and denominator cancel one another out, what are you going to put down? 1. We're going to put a 1. Each of these, I think, should simplify further. In the last term, I have 10 divided by 5, which is 2. And a cubed divided by a, which is a squared. And b to the fourth divided by b is b to the third. None of those are like terms, are they? So we can't go any further. That is simply my answer. It's possible that we could have variables still less than our denominator. It's possible that an entire term might simplify or cancel out. Let's try this one. This one's written differently, just written horizontally as opposed to as a fraction, but it's meaning the exact same thing. Yes. Would you please give these? There's a couple other papers and I can make them into their owners and stuff. Thank you. Okay, so in this problem, when it says dividing by 4 CDF, that means we're taking that numerator and then we're dividing each term by 4 CDF. Okay, I'm not just dividing one term, I'm dividing every single term in there by 4 CDF. So let's simplify each individual term. In the first term, I'll start with my coefficients. 20 divided by 4 is 5. C to the fourth divided by c is c to the third, c to the third. And d squared divided by d is d, and f divided by f is going to cancel. For the second term, we have negative 16 divided by 4, which is negative 4. C divided by c is going to cancel, and d divided by d also cancels. F squared divided by f is f. So I just have minus 4f as a second term. What's going to happen in that last term? It's all going to cancel out, isn't it? Now, don't put nothing there. You have to put something. 4 divided by 4 is not 0. 4 divided by 4 is 1. So we are going to put plus 1. And of course the C's do cancel, D's and F's. This is another way they could write a division problem. So this time we have a quantity to the negative 1 power. What does the negative exponent tell us is going to happen to that parenthesis 3xy? It's going to go to the denominator, okay? Because wouldn't this be 3 to the negative 1, x to the negative 1, and y to the negative 1? All of which is going to go to the denominator, isn't it? So really my problem looks like this. 18x squared y plus 27x cubed y squared z. And then all of this divided by 3xy. Okay? It was all taken to the negative 1 power. So we're going to divide each of those terms by 3xy. And I think you guys can probably do this without breaking it into two separate problems. If we can visually see what we're dividing here. So if we start with this first term in this denominator, 18 divided by 3 is 6. X squared divided by x. And y divided by y. They're going to cancel. Now for my second term, I have 27 divided by 3, which is 9. X cubed divided by x is x to the second. Y squared divided by y is y to the first. And then z. Okay, let's look at one like this. 3x squared y plus 6x to the 5th y squared minus 9x to the 7th y cubed. And that is all divided by 3x squared y. Okay, so we need to divide each term by 3x squared y. Let's go ahead and do this. 3 divided by 3 is going to give us 1. X squared divided by x squared is going to cancel. And y divided by y is going to cancel. So really that whole term cancels. What do I have left there? 1. Put a 1 there. For the second term, 6 divided by 3 is 2. X to the 5th divided by x squared is x to the 3rd power. And y squared divided by y is y to the 1st, or just y. For the last term, negative 9 divided by 3 is negative 3. X to the 7th divided by x squared is x to the 5th power. And y cubed divided by y is y to the 2nd power. Which would be letter B. There's one other example I would like to show you. This will be our last one. We have this one. So we have 2xy z to the 3rd minus 6x cubed y to the 4th z, all divided by 8x cubed y squared z to the 5th. Okay. So I'm dividing each of those terms in the numerator by 8x cubed y squared z to the 5th. This one's going to be different because it doesn't all work out perfectly. If we start with our coefficients, I have 2/8. What does the fraction 2/8 simplify to? 1/4. 1/4. I have x divided by x cubed. Well, 1 minus 3 is -2, isn't it? So where will that put x? In the bottom. I've got x squared in the denominator. For my y's, 1 minus 2 is -1, so where will that put y? In the bottom. Okay. And again, isn't 2 bigger than 1? So I know that it's going to go in the denominator. Z cubed divided by z to the 5th is z to the 2nd. 3 minus 5 is -2. So where will z squared go? On the bottom. Okay. That is one term. Don't get it mixed up with the second term. It's a totally separate fraction. For the second term, I've got -6/8. What does the fraction -6/8 simplify to? -3/4. Okay, totally separate fraction. X cubed divided by x cubed. So I'm going to cancel. And y to the 4th divided by y squared is going to be y to the 2nd. Where am I going to put y to the 2nd? On top. And z divided by z to the 5th, well, 1 minus 5 is -4, so where will z to the 4th power go? On the bottom. So we could still have stuff left in our denominator, couldn't we? It just depends on what our exponents look like. And they're two separate problems. Don't try to put it all over something. It's two separate terms. Okay, so we are dividing a polynomial by a monomial today. And you have an assignment, and it's out of the book. I think. Also, I have your quizzes done, and they are posted on 6. I don't want to show you just yet because I still have another class that needs to take it. So you guys do have that done. You want to see? You can check it out. So on page 345, let's do numbers 1 and 2, page 12 through 17.